Welcome to 4.7 inverse trig functions, the last section before you will go on break. So our objectives are interpret the effects transformations have on functions and find inverse of functions. And our central question is, how can we find the angle if we know the value of a trig function? So inverse functions. If no horizontal line intersects the graph of a function more than once, the function is one-to-one and has an inverse function. So if point AB is on the graph of f, then point BA is a point on the inverse function. So f of negative 1. The graph of f of negative 1 is reflected of the graph of f. That sounds very confusing. It's not as confusing as you think. So if we look at the inverse sine function, the horizontal line test shows the sine function is not one-to-one. Y equals sine of x has an inverse function on your restricted domain, so it's only between that period. Negative pi over 2 and to pi over 2. So your inverse sine function is denoted by sine negative 1, or inverse sine, and it's between that period. So you read y equals the inverse sine of x. So y equals inverse sine of x really means sine of y equals x. So these are interchangeable, so you can change your numbers around. So this is your graphs. So one way to graph y equals inverse sine of x is to take points of the graph of your restricted sine and reverse the order of your coordinates. So I would copy this, take a picture of it, something, write it down, you will need it. There's also a sheet under your resources that has your sine, cosine, and tangent charts on it if you would like to print that off. So finding the exact values, let theta equal inverse sine of x, rewrite it so it's sine theta equals x, and then use the exact value table. So again, under resources, there is a Word document that has all three of your exact value tables on it, so you don't have to memorize them. So let's do an example. You have inverse sine of square root of 3 over 2. So we want to rewrite it after. So we're going to I'm very sorry. We're going to write it first. So we have theta equals sine square root 3 over 2. That's step 1. Step 2 is to rewrite it as sine theta. So you have sine theta equals square root of 3 over 2. So now you would go to your chart and see where sine theta equals square root of 3 over 2. So go to your chart. Square root 3 over 2 is at pi divided by 3. So now you have the angle in negative pi over 2 to pi over 2, whose sine is square root of 3 over 2, is pi over 3. So in this example, we're just going to rewrite it again. Even though it's up top, just rewrite it. Now we're going to rewrite it in its new form. So you have sine negative square root of 2 over 2 equals theta. So then you go to your chart, and you want to look up negative square root of 2 over 2. Which is your negative pi over 4. So let's look at some cosine. So horizontal line test shows us the cosine function is not one-to-one either, but this one has the restricted domain of 0 to pi. So you're going to rewrite it the same way, so y equals inverse cosine of x means cosine of y equals x. So one way to graph y equals inverse cosine x is to take the points on the graph of your restricted cosine and reverse the order. So to find the exact values, it's the same thing as your sine, only with cosine. So you're going to rewrite it as theta equals inverse cosine of x, so you're going to rewrite that as cosine theta equals x, and then find the exact values. So let's do a couple examples. So we have theta equals inverse cosine of negative 1/2. We want to rewrite that, so you have cosine theta equals negative 1/2. So you want to find where it says negative 1/2, and that's going to give you 2 pi over 3. And that's your answer. So make sure you complete the questions below and then watch the next video. In the next video we're going to talk about inverse tangent and then how to use your calculator to find inverse function.